Okay, today we will be starting with our unit 2.1, that is solar PV modules. So solar PV system, one of the component, that is the solar module. So the basic component from which a solar module is made, that is solar cell. Okay, that we have already discussed in our previous units. So the limitation or the capability of one solar cell, that is very less as compared with the requirement or the load requirement. Okay, like taking an example, the single solar cell, it can generate 6 watt hour to 10 watt hour energy. Whereas the daily residential and commercial requirements, they are much larger. Okay, so one solar cell, that is not sufficient to meet the requirement of our regular load as well. So what is the solution? In that case, we need to connect several solar cells in series and in parallel, and thereby this solar module that is formed. So here is a solar PV module. So a number of solar cells, they are connected in series, then they are connected in parallel, so that the total output, the voltage, the current available between the positive and negative terminals of the module, that is as per our requirement, or that which can further be utilized. Okay, maybe if it is not as per our high requirement, then we need more modules to be connected, but that is as per our load requirement. So bypass and blocking diode, both are shown here, so that we have already discussed in our previous classes. The amount of output current from a solar PV module is directly proportional to the solar irradiance. The output of the solar module can be increased by connecting more cells in parallel. Okay, the current that increase when we connect solar cells in parallel. Solar cell voltage primarily depends on its temperature and not on the solar irradiance. So two quantities we are measuring here, solar irradiance and temperature. PV modules, when formed by connecting the solar cell in series, can operate at different voltages. So to increase the voltage, we use series combination. The number of solar cells and the way they are connected in a PV module determine the current and voltage that the module can provide. How many number of solar cells we have connected in series, that determines the voltage. Then how many modules connected in parallel, that determines the current. So we make a series and parallel combination to achieve our desired voltage and current requirement. So there is a tip now. Irradiance means the total solar energy received per unit area in form of electromagnetic radiation. Coming to the characteristics of solar PV modules, the first of all, commonly available PV modules, they are monocrystalline silicon solar PV module, then silicon solar PV module, cadmium telluride solar PV module, amorphous silicon solar PV module, and CIGS solar PV module. Most commonly used commercially in the rooftop installation as well. Either they are monocrystalline silicon solar PV module or multi or polycrystalline solar PV modules. Comparing the efficiency of different type of solar modules, so advanced crystalline silicon modules, they are having more efficiency, more than 18%, and commercial modules of monocrystalline silicon solar cells 12 to 16%, modules of polycrystalline solar cells, that is 11 to 13%. Means monocrystalline, they are having a higher efficiency as compared with polycrystalline. Amorphous silicon modules between 4 and 8%, copper, indium and selenium modules 11%, commercial CIS modules, that is below 10%. Okay, then the high efficiency modules, they are gallium arsenide solar cells. Usually it is used in space applications. Okay, like in the satellites, they are also having this solar module, so that the satellite can work. From there it gets the electricity. Okay, their efficiency is very high, more than 20%, and it can reach up to 30%. Into the lifetime, so the performance guarantee of most of the crystalline silicon commercial modules, that is a minimum of 20 years. It can go up to 25 years. So depending on climate and region, the energy payback time ranges from 2 years to 6 years. So most amorphous silicon modules available in the market have a stable efficiency level that is ranging from 4 to 8%. And the estimated energy payback time of amorphous silicon modules, that is 1 to 3 years. So what is this energy payback time? That is energy input upon energy saved. So energy input, that consists of all of the energy that is being required from manufacturing to installing, then they're operating, then decommissioning it. So all of that is input energy. Then output energy, that is the annual saving of energy from the electricity produced by the PV module. Important features of PV modules are listed here. So first one is the solar cell converts radiation energy into electrical energy when sunlight falls on it. Okay, that is a common feature. Since solar cell is a basic component of a PV module, it generates electricity only when sunlight falls. During night, we are not having any type of electricity from the solar module. The amount of electricity which a PV module can generate depends on its physical size. Larger the area, more energy will be generated. PV modules are mainly characterized in terms of their power rating. So that is peak power. That is an important term, because while using a solar panel, while installing it, while selecting it, we always check the rating, WP, that is peak power. That is the maximum power rating that a PV module can provide under best condition or under standard test condition. STC, we write it in short, standard test condition. So when in the market, from 1 watt power, 1 watt peak to 300. Okay, the watt, that is the peak power, 1 to 300, that is available. From a PV module that is in DC, the form of DC, direct current. And the devices commonly used in household, they are usually using AC, alternating current. So we need an inverter to convert the DC into AC. Since PV module generate electricity only during daytime, and what about the requirement during night? For that we need energy storage. So most commonly battery we are using. So the energy generated, electricity generated during daytime using the solar availability, that is stored in the battery. Because some of the devices, if it is running on DC, then they can directly be connected from the battery. Okay, we don't need an inverter in that case. Okay, now we need large energy. The one module is not sufficient to provide that our requirement. Then we need more modules. We need to interconnect it, and that becomes a PV module array. Interconnection of different number of PV modules. And the graph, current and voltage characteristics of a PV module, they are shown with two type of variation in the irradiance, then second in the temperature. Now what is the effect of that? So here on the graph, V, voltage, that is on the x-axis, and current is on the y-axis. Now the irradiance, that is varying, that is changing. So in the first graph, we see that as the irradiance is increasing, the output or the current, that is increasing. In the other case, okay, when the temperature, that is varying, so the difference, current is almost constant with a change in temperature, but voltage, that is varying. Temperature is increasing from 20 to 25 to 30. The current, that is decreasing. Means the temperature should be less. You should not let the PV module, the temperature of PV module to increase. Otherwise, the output, that will decrease. Now coming to the power, voltage versus power curve of a solar PV module in accordance with varied irradiance and varied temperature. So here also we see that as the irradiance is increasing, the generated power, that is increasing. Okay, but As the temperature is increasing, the generated power is decreasing. Okay, from 20 to 25, that is less. Then to 30 degree, it is even less. Coming to rating of PV modules. So the specifications which are giving, which are already specified while purchasing the PV module, while selecting it. So they are under standard test conditions. Under standard test conditions, the temperature is taken as 25 degrees Celsius, irradiance 1000 watt per meter square. In sunlight spectrum, that is air mass, it is 1.5 G, that is global. The solar radiation is corresponding to the condition when solar radiation travels 1.5 times the thickness of the Earth's atmosphere. So that is why it is called air mass 1.5. So the real power produced by PV module installed in a field, so that is subject to the difference in temperature, in the spectra, in the irradiance. The power actually obtained, that may not be as much specified. It could be less than the peak power. So under different conditions, standard condition, after that under different conditions also, we need to study the output. Like in some area there is usually temperature is high. In India many areas are like that, so the output will not be the same. It will reduce with increasing temperature. So the International Electrotechnical Commission, so the Technical Committee 82 Working Group. Okay, this is a specifying body, regulatory body that has framed one of the most pertinent PV standards. So standard about this. So photovoltaic panels. That is IEC 61853 standard, and the title Photovoltaic Module Performance Testing and Energy Rating. That is IEC 2011. So here are some of the sections specified in IEC 61853. So first section specifies the measurement of temperature and irradiance and power rating of a PV module. It specifies the needs for assessing the performance of a PV module as per its power rating at different temperature and irradiance. Something similar in the curve which we have just studied. The second section specifies the measurement of incidence angle, spectral response, and the operating temperature. Then it specifies about the testing methods used for measurement of the effect of changing angles of incidence and sunlight spectra. It also describes the estimation of the speed of wind, temperature of the module from irradiance as well as the ambient temperature. Third section specifies the rating of energy level of PV modules. It specifies the calculation involved in this rating in watt hour. That is related to power, energy, watt hour. The fourth section specifies the standard time span and weather condition which are ideal for calculating the energy rating. Electrical parameters are determined at STC, standard test conditions. So rated specification of a PV module are determined for the maximum power point of the current and voltage curve of PV module, maximum power point at which the maximum power is available at some specific current, at some specific voltage. The PV modules are sealed to protect them against moisture, pollution, corrosion, and weathering. In this way, the performance specification of the module can be guaranteed. Means it should be totally isolated to glass. That's why the glass is there. That is made strong. Wind cannot be distorted. Look at all the water that is rain during rain time or during the dust which is flowing. So it should be protected from all of these type of environmental conditions.